now. Let's convert them to radians. Like, okay, um, every experiment needs to have three things in it. So every time you design an experiment, and hopefully someday in your life you get to design an experiment just for fun, even like with your children, something. Because I don't know, I think it's really fun to do. But you need to have three different things, very important. And the first one is some kind of randomness. So this is called random assignment. Let's talk about the difference between randomly selecting and randomly assigning. Okay, first thing you need to know is you should never randomly select someone for an experiment. That is unethical. You cannot make someone, except for me tomorrow, do an experiment. They should always be volunteers, except for you won't be tomorrow, except for that one. All other ones in the whole world, you should never randomly select someone to be in an experiment. Terrible idea. Random assignment means that you have a group of volunteers that came willingly, not dragged, totally volunteered, and then you randomly assign them to what treatment they're going to get. Which means you need to have a place for everybody. Randomly selecting, you're just taking a few out, right? Randomly assigning means you're taking everybody and putting them in specific groups. You guys see the difference? A random selection, you're only going to have a few out of a big group. Random assigning means you have a big group and you're going to put them in different treatments. Okay, so what does that mean? It means that we need to treat table D and the hat and the technology a little bit differently for random assignment, which we're going to do after this. Okay. Keeping other variables constant for all experimental units to help reduce the variability in the response variable. That's called control. You guys, have you ever heard of experiments being controlled? So my kid last week did a sleep study. You guys know what a sleep study is? Like you sleep with that machine on and then like okay, so for control purposes, they said, do not eat after 8 p.m. Do not have any caffeine after 6 p.m. They're giving you all of these ways to control the results to make sure that the effects of the study can be seen clearly. That's what control is. So they're going to give you a lot of like rules in an experiment so that you can really see the outcome. And the last one, repeating each treatment to enough experimental units so a difference in the effects of treatments can be distinguished from chance variation, or just use enough subjects to be able to show a difference. This is called replication. Meaning you replicate the experiment enough times so that you know that it's not just this guy. It's not like anecdotal evidence. I don't know, I'm a weirdo, so I'm really interested in keto diet and carnivore diet and fasting, like intermittent fasting, which are all things I should do. Don't want to do any of them, but because they're all hard. But the guy that was talking about the carnivore diet, he was being very specific to say that he only has anecdotal evidence. Do you know what that means? Do you guys know what anecdotal evidence means? It just means like stories from specific people where it worked. They didn't do an actual experiment to see whether or not it worked. They just listened to people's stories. And so he had to be very careful in the podcast and not be like, I claim that this works for everybody. It's just worked for these particular people who gave me this story. There wasn't enough replication. There wasn't a formal experiment done. It's just a few people that it worked for. Okay, so now we're going to get into types of experiments, and there are three that the College Board might ask you about. So very specifically three. The very first one, which is a regular type of experiment, we didn't do anything specific to it, is called a completely randomized I have to put the N in random. Design. Completely randomized design. And this is like regular style, a regular old experiment. Okay, so this is what you have. And we're going to draw a little diagram. So in all of these, I don't know if you noticed on the next page, there's like a lot of space because we're going to draw little arrow diagrams. Okay, so you have your experimental units. And those should be volunteers. If they're people, if they're just objects like shoes, not a big deal. You don't have to worry about the feelings of the shoes, but if they're people, they should definitely be volunteers. And then you're going to do some sort of random assignment. Okay, and when I say that, I want your brain to go hat, technology, or table D. And you're going to randomly assign them to different groups. We're going to do a very basic one here. So this is going to be group 1, group 2. Seagull is very interested in our experiment. Group 1 will get treatment 1. Group 2 will get treatment 2. And I'm not saying that one of them is a control group, but a lot of times one of them will be a control group that gets a placebo. Sometimes it's not ethical to do a placebo. Think about people with a heart condition. You want to take them off their medication and give them a placebo? Not a good idea. But you could do old medication and new medication. That would be treatment 1 and treatment 2. A lot of times it's a placebo. A lot of times you'll have more than one group or more than 2 groups, but this is just as simple as it could possibly get. Do you guys have any questions about my diagram here? Good? Simple enough? Okay, flip to the next page. Okay, the next one is called randomized block design. The random assignment of experimental units to treatments is carried out separately in each block, which are groups that are known to share a characteristic. A lot of times you should not compare results from things that are very different from each other. So it's best to separate out into different groups and then do separate experiments. Okay, so I'm going to try to write this a little smaller this time. So experimental units. And then you separate those into blocks. This separation is not random. You're breaking them into groups that are by age group, or I hate to mess with gender, but by gender, by height, ethnicity, color, weight. I was trying to think of objects. Different manufacturers like Toyotas and Hondas and Fords and Chevys and anything that just separate groups that are similar for some reason. And then what you have to do is you have to imagine that these are really basically two separate little baby experiments. So this guy's going to get his own complete experiment. This guy's going to get his own complete experiment. So then you do the random assignment. And you guys all know there might be more than one treatment, right? Just putting two here to keep it as basic as possible. Okay, and what this allows you to do is it allows you to compare this group to itself. So all of the short people, let's say, and you could compare all of the tall people. And then at the end, if you wanted to, you could compare the short people to the tall people. Sometimes that makes sense and sometimes it doesn't. I said short and tall because we're going to do one about height tomorrow, design one. You should sort of get the feeling that this is very similar to a stratified random sample. It's just for a different purpose. It's an experiment. Strata and blocks are kind of similar. Okay, last one, but there's two different styles. This one's called matched pairs. Two very similar experimental units are paired, and both treatments are given to both experimental units in a random order. Okay, so this one is going to look a little weird. Luckily, the one that we do tomorrow in class is going to be matched pairs. So this will make a lot more sense after you actually do it. Okay, I'm gonna go with Ellen's example from yesterday. Well, Ellen was telling me that yesterday was National Coffee Day. Um, so I think today's, she told me, was National Love People Day, which is cool. But we're gonna go with National Coffee Day for my example for this. So let's say that there's a theory that if you have more caffeine, you type better. Okay, so they have a group of volunteers. They randomly assign using either hat, technology, or table D. It's never going to be table D because they why? Why would you? Why? But you know, anyway. And randomly assign you to drink caffeinated coffee or decaf. And you don't know which it is because it's an experiment, so you don't want to have any kind of effect, right? Okay. And then they measure your typing speed. Does that make sense? Okay, then what you're gonna do is you're gonna come back a week later and you're gonna switch and do the other one. So that's what matched pairs is. So our arrows are gonna crisscross. In this case, they're most likely going to do some kind of math to subtract your words per minute in one from your words per minute from the other and find a difference, and then they will compare it. Another example, this is really weird, but I don't know if you've seen like these Instagram posts where somebody's got like night cream on one side and not the other side of their face. And like then they measure like after a certain amount of days if this side of your face like has less wrinkles than this side. That's a matched pairs experiment. One side of your face being one experimental unit and the other side of your face being another experiment, which I think is really weird. And I would never do that because what happens if like I lose all of the like under eye wrinkles on this side, but not this side? I don't know. I couldn't do it. I couldn't do it. Me? Well, I don't know about that. I do a lot of laying in the sun, which is not good for your skin. Okay, now this one is a little bit different. And I'm going to call this twins. So this is pairs where you're paired with yourself, basically. And this is basic. I say twins, and it doesn't have to actually be twins. It just has to be two very similar things. But when I say twins, everybody gets it. Okay. And so you separate them. And we're going to do 3 sets here just to make sure that it makes sense. The number of them that you have doesn't matter. There's actually a really super cool study. I was watching this Netflix documentary about they gave twins one diet. Did you guys watch this? It was recent. They gave like one twin like the Mediterranean diet and another twin something else. You think because I was going to talk about it in class, I'd have more information, but I was like, man, that's really cool. And there's also like another study, which is really, really sad, which I hate mentioning, but they took these twins that got separated at birth and like measured different things about them due to their environment.
In like 18 similar, I did like alcoholism and if it's like genetic or if it's just like environment.
Exactly. Anyway, sorry, I just found that really fascinating. I should find that Netflix documentary again. I don't know. So anyway, Mrs. Talbot, maybe next time you should give up more room here. You had to go like note card size writing in this one. Okay, so the cool thing about this is you could compare between the twins. It was fun because I had Lily and Tess in the same period last year. So every time I did twin stuff, it's great. It just totally pointed Lily and Tess, which were they are very much the same and very much different in a lot of different ways, which is super cool. But anyway, they're right here, by the way. They changed their main test to Lily test. So I have them right here all the time. Okay, so that's it for the blue pages for today. If you guys could find your notebook. Well, I was trying to be nice about the large amount of homework I assigned.
Very nice.
Oh, but I told you I was gonna be flexible. I would like to stamp tomorrow.
No, I'm good. Kind of happy I thought I had to send to this. Yeah, because then I would know about it.
I'm sorry.
No, it's better like this. Yeah, or else I would have procrastinated it all for 2 months.
Oh, well, that's usually why I stamp every day. It's just that this particular, I told you, is Lucy. I don't know, not my comfort zone with how long it took. Okay, so my goal for today is to fill these in, which is basically just the differences between random selection and random assignment for these things. And then we did not write this yet. And then paste in this last thing into the notebook, which is the walk text thing. So I want to fill this in and then paste this in, and then we can be done. And that will leave us plenty of time to do our experiment tomorrow, which I'm super excited about. I don't know if you can tell. I actually wasn't. I actually sort of. She was like, "Your kids need to get off the field," and I was like, "No, it was just like it was." But they were all yelling it, and I was just like, after we did Sugar Rush, I don't care about that anymore because like, everyone. I know. So there's no rule to me anymore. So you've ruined it. My kids can walk on the field, whatever. And she was like, I know. It's about high heels, apparently, because if you walk on the field in high heels, it voids the warranty. This is what Mr. Regalado told me yesterday. I know. I'm not just like, I couldn't think of any reason, but then he did give a valid reason. So I was like, okay, fine. Because the people who did Sugar Rush had proper footwear because they were going to run, which made sense to me. But I was irritated when they were doing it because I was like, they yell at us to get off the field during every single drill, and then now the kids are all over the field. So, but whatever. It's fine. I just work here. It's great. Okay. Now, so when you're designing an experiment, you're going to have different groups for your experimental units. Does that make sense? Okay, the most basic one would be half and half. So half treatment, half placebo or something like that. That's the most basic you would get. So if there's 28 people in this class, you would have 14 be in your treatment group and 14 be in your control group at the most basic level. Everybody got that? Okay, and if you had 4 groups, let's say running, walking, standing, sitting, something like that, then there would be 7 in each. You need to establish kind of how many you need in your group before you start randomly assigning. So first, in all of these cases, you need to establish how many people you need to be in having your group. Now, this is a weird fact about our experiment tomorrow. They're not going to be even groups. And that's because the computer, so I told you it's about clicking the mouse. When you go up to do the experiment on my computer in front of everyone on the screen, which is gonna be so fun for me, it's going to randomly assign you to one of two groups. The computer does it. So you don't really know how many are going to be in each group. Roughly, it should be half and half. But since the computer does it, you're not sure. But when you're designing an experiment, you should assume roughly half and half. And if you're assigning it, say like, I don't know, you were doing a clinical trial for Alzheimer's and you wanted to know who was getting the new drug and who was getting the placebo in Grey's Anatomy, then you would definitely make sure that it would be half and half, and you would definitely make sure that your boss's mom was not in the treatment group because you put her there because you wanted her to try the new drug and not have the placebo. Am I the only one who watches the show? Okay, I am the only one. Yeah, it's a good show. It's a good show. I stopped watching it. There was this episode where this guy was like disappeared into the fog, and I was like, you know what? I'm done. Like, how many disasters can these poor people have? And why do they always occur on the last week of the season? Anyway, okay, so randomly assigning. So you're going to take all experimental units and assign to roughly equal groups based on the number of treatments. Okay, so that's what you need to know. You're not randomly selecting people. That would be unethical. You're taking your volunteers or your objects and you're putting them into roughly equal sized groups. Okay, table D. Number experimental units. This is going to sound familiar though. Number your experimental units using the same number of digits. So let's say we were going to do our class. That would be 0, 1, 2, 30, 28, 28. Does that make sense? About the same size digits? Okay. 2. I did not want to put and again, it's kind of silly to do no repeat because you're only asking it for one number, but that's okay. Does this make sense though? One number of rows, one. Do you want me to show you what I'm talking about? Okay, so if you remember to back to table D, you don't have to get yours out. I have mine right here. So table D was numbered from 1 to row 35. So we did 1, 35, 1 to give us the row number to start at. Do you see what I mean? And like the one in the back of the book, it's like 101 to something. So you'd go 101 to whatever, comma 1. Okay, anyway. Read the integers from left to right, ignoring repeats and numbers outside of your range. That's the same as it was before. Okay, here's where the difference comes in. So your first numbers that you get will fill your first group, and then the next numbers will fill your second group, and then keep going, and then the leftover will be in the last group. And that's kind of a theme here. The leftovers are always in the final group. But do you see the difference with the filling instead of selecting? Like you're filling these treatment groups. Okay, we're almost done. I promise. Hat. Guess what we do first? Yeah, number. Uh-huh. Guess I didn't need an extra space. Okay, for this last bit, can you guys get your calculator out? Okay, so the technology bit has a little bit of a nice feature to it. So the first number. Okay, so let's pretend that we were going to, yeah, let's pretend that we were going to randomly assign you to 2 groups in this class. So after you write this, grab your calculator. I want to do something different. Instead of randomly selecting people, I want to arrange. Okay, and so I'm going to go math probability. No repeat. But we have 28 people in this class. I'm going to say the lowest number I want is 1. The highest number I want is 28. Give me 28 numbers. And what it will do is it will arrange them randomly. So then the first 14 could be your treatment group, and the last 14 would be your control group. Now, real quick, if you want to see, anytime we do this, if you want to see the numbers in the arrow, you have to hit the right arrow immediately. You can't hit any other buttons on the calculator, otherwise it goes away. So if you want to see what these numbers are, which it really wouldn't matter, all you need is the first 14. So get the first 14 would be your treatment group. All the rest would be your control group. But if you want to scroll and see those other numbers, you have to do it right away. Because if I hit any other number, I can't go back. Look, it won't let me scroll anymore. So you have to redo it. Just a hint that I've come across by making lots of mistakes in the past. Okay, if you guys could grab a basket and just put this in and set that up for tomorrow, that would be perfect. And then I do have a joke for you. Why does it feel like it should be a block day today? Halloween is still good. I like Halloween still.
No, I do too. I trust the outlook. It's stressful.
Oh, Halloween? Math teachers are trying to do a costume again like we did last.
Oh, cute.
We were on the Seven Dwarfs. Which one was I? I was Bashful, I think. Oh no, he's hold on, let me